In this video, I will explain how to find the critical path in a network diagram. So let's say that we're given some project right here with 7 activities. In a previous video, I showed how to use the forward pass and the backward pass method to create this diagram right here, where each of these boxes has 6 squares, where the square in the middle shows the activity name, the square in the bottom middle shows the duration of the activity, and then we also have the early start, early finish, late start, and late finish of each activity. Now, once you have all of this information, you have everything that you need to find the critical path. And the critical path is simply the activities that cannot be delayed without increasing the duration of the entire project. Now, the easiest way to find which activities these are to identify the activities where the early finish is equal to the late finish, or equivalently, the early start is equal to the late start. So that's it. That's all you have to do. Now, if we look at our network diagram down here, we can see that activity A has the same early finish and late finish. So let's go ahead and box activity A. This is on our critical path. We can also see that activity B has the same early finish and late finish. So let's box that one in as well. Activity D also has the same early finish as late finish. So we'll box that one. And activity G has the same early finish and late finish. So we'll box that one in as well. So for this particular project, the critical path is activity A, B, D, and G. And what that means is that if any of these 4 activities are delayed by even a single day, then the entire duration of the project will increase. And to understand that, let's just take activity B as an example. This tells us that the latest, this 3 right here says the latest that activity B can start is day 3 without delaying the entire project. So imagine that it starts on day, let's say 4 instead. If it started on day 4, so it got delayed by 1 day, the duration of activity B is 4. So it wouldn't finish until day 8, because 4 plus 4 would be 8. This 8 would then get carried into the earliest start for activity D. This would be an 8 as well. And we know that activity D has a duration of 5, so the earliest that it could finish would be a 13. So this would become 13. Then this early finish of 13 would get carried into this early start for activity G of 13. So this would be a 13. And then activity G has a duration of 4, so 13 plus 4, the earliest it could finish would be 17. So we can see that just by delaying activity B by 1 day, we increase the duration of the project from 16 to 17 days. But the same is not true of these 3 activities right here that are not on the critical path. And again, as an example here, let's just consider activity C. This tells us that the latest that activity C could start is day 10 without delaying the entire project. And we can also see that the earliest that activity C could start is day 3. So what this means is that even if activity C got delayed, instead of starting on day 3, let's say it got delayed 7 days and it didn't start until day 10, this would still not affect the duration of the entire project, because the duration of just activity C is 1. So if the latest it could start is 10 and it has a duration of 1, the latest it could finish would still be 11. And again, this 11 would get carried into activity F, and we can see the duration of activity F is 1 day, so 11 plus 1 is 12. Again, that tells us the latest that activity F could finish is 12, and this 12 get carried into this late start for activity G, and then we would have a duration of 4 for activity G, so 12 plus 4 is still 16. So even if activity C got delayed and it didn't start until day 10, it still would not delay the entire project. And that's the whole idea behind a critical path. So wherever the early start is equal to the late start, or equivalently, the early finish is equal to the late finish, whenever these values are equal, basically what it means is that there is no wiggle room for this activity. This activity cannot be delayed without increasing the duration of the entire project. So that was just a quick example of how to find the activities that are on the critical path of a given project.